So today we're going to start section 10.4, and in section 10.4 we are going to talk a little bit about tree diagrams. Right, as we go through this section and later on in the chapter as well, we're going to be using the counting principle. So the counting principle states, if a first experiment can be formed in m distinct ways, and a second experiment can be formed in n distinct ways, then the two experiments in that specific order can be performed in m times n distinct ways. So basically we're going to take the number of ways that each experiment can be performed, and then we will multiply those together and find the product, and that's going to be our answer. Right, so a list of all possible outcomes of an experiment is called a sample space. So one of the things we'll be doing in these problems is listing out our sample space after we're done with our tree diagram. Each individual outcome in the sample space is called a sample point. Okay. And then tree diagrams is what we are going to be drawing and using. They can be helpful in determining sample spaces, so that's how we're going to be using these. All right, so in example 1, we are going to select marbles without replacement using our tree diagrams. So for part A, 2 marbles are to be selected without replacement from a bag that contains 1 red, 1 blue, 1 green, and 1 orange marble. Use the counting principle to determine the number of points in the sample space. Right, so we have 4 different colors in there. So the first marble, we're going to have 4 choices. And then since it's without replacement, that means whatever color we pick out the first time, we're going to keep out. So that means if we started with 4 marbles, we picked 1 out, well now we have 3. So using our counting principle, 4 times 3 is going to give us 12 points in our sample space. All right, so to start our tree diagram, I started with just kind of our basic image here. And looking at this, we're just going to use kind of abbreviations to show the different possibilities. So the bag contains 1 red, 1 blue, 1 orange, and 1 green marble. So this represents our first pick. Right? Now, if we pick a red marble, well, we can't pick a red one again. So we could pick a blue, orange, or green. Right? If we pick a blue marble, we can't pick blue again. So we're going to have a red, orange, or green. If we pick an orange marble, then we're going to have a red, a blue, or green. And if we pick a green marble, then we would have a red, blue, or orange. Right, so basically we can't reuse the same marble once it's been picked and chosen. So then what we're going to do here, so again this first represents our first marble, that represents our second marble. Now we're going to list out our sample space. All right, so for our sample space, looking at this first one, well, we could draw a red and then a blue, a red and then an orange, a red and then a green. Right. Looking at kind of this little group here, well, we could do a blue and then a red, a blue and then an orange, a blue and then a green. Right. Then we could do orange, then red, orange, then blue, orange, then green. Right, and lastly from our group down here, green and then red, green and then blue, green and then orange. So if we look at our list of our sample space, we have 12 different possible cases, and that's what we got from part A using our counting principle. All right, so now that we have our sample space, we're going to find a couple of different probabilities. And I'm going to go through and kind of notate these, and as we're going through these different problems and some of the stuff in the next sections as well, just kind of highlight these using different colors. Right, so our probability of selecting an orange right, so in our sample space, we have an orange selected in this case. In this case, all of these have an orange, and then we have one down here. So if we count total, our probability of selecting an orange, 1, 2, 3, 4, 5, 6, divided by the size of our sample space, which is 12, and then we can reduce our fraction to 1 out of 2. Okay. So we used our sample space, and then we looked for, right, our particular event that we were concerned about was selecting an orange, and we counted those in our sample space to get our probability. Right, so for D, we're going to do the same thing. Right, only this time we're determining the probability that a green marble followed by a red marble is selected. Well, looking at our sample space, we only have one case where we have a green and then a red. Right here is red green, so that won't work. We just want green and then red. So in this case, we're just going to have 1 out of 12 for our answer for this one. Right, so we started by using our counting principle to determine the size of our sample space. We used a tree diagram then to construct our sample space. We listed it out, and then we used that sample space to find our two different probabilities down here for the last part of our example.